And what we're going to do is what's called proportional relationships. And proportional relationships are simply sequences that when they are graph through 0. So as long as this set of numbers is a sequence, and when you graph it, it goes through 0, you have a proportion. So if you can see, here's a set of numbers. So between 90 and 45, we have 45. So we have a difference of 45. So it's a sequence. And then when you graph those numbers, 1 and 45, and 2 and 90, and 1 and 135, or 3 and 135, you can see the points right here. They create a line that goes right through 0. So that's proportional. So that work is right here when we go through and see that it's a sequence. Now what we want to be able to do is write an equation. So writing an equation of that is, once we know it goes through 0, we're going to use the y equals ka, or kx I mean. And all we need to do is know what k is. Well, k is the proportional part, or the y over x. So y over x is 45 over 1. So if we write our equation, we're taking the slope, or the change, which is the difference, and making our equation. So there's the answer to that. So now we can take this and predict the amount of money if we want the number of clients, because x is the number of clients. So I have my 45, and in this case it's 8, so if we put 8 in there, then we can predict that we would have $360 dollars in bonus if we have 8 new clients. And so there's the answer. Now a non-proportional is a sequence, and see, you can look at this problem, it's a sequence, but the problem is it doesn't go through 0, so we can't use that equation. So we want to be able to create an equation, and all we're going to do is we're going to start with, oops, my fault, we're going to start with y equals kx, which we know what k happens to be 3 in this case. But the difference now is it's not proportional, and where it crosses the y-axis, which in this case is a 6, is we have to add that on. And so what we create is a slope-intercept form. And we create that. Now the other thing is I want to remind you is that this is asked for function notation. F of x is the same thing as y. So I'm going to go back to what we talked about. Y and f of x are the same thing. So if we look, there's the f of x, or function notation, of this equation. So we start with this equation, and we see the graph that it crosses at 6 instead of 0, so we add that 6 on. Now if it crossed at -2, we'd have a -2.